In this video, we're going to learn a method to evaluating trigonometric integrals. More specifically, we're going to look at integrals that involve powers of sine and cosine and powers of secant and tangent. To evaluate these integrals, we don't need a new technique. We can simply apply a use substitution and make use of several trig identities. There are 4 trig identities that we'll be using in this section. The first 2 involve relationships between sine and cosine, and a relationship between secant and tangent. The last 2 are what are called half-angle identities. Now, the form given here are expressed in terms of double angles, but it's the same equivalent statement, just expressed in a different way. All 4 of these we'll be utilizing throughout the section. So let's take a look at an example. Let's say I want to evaluate the integral of cosine cubed times sine squared. What I'm going to do is a clever use substitution. The first thing I'm going to do is I'm going to rewrite cosine cubed as cosine squared of x times cosine of x. I'm going to do that, so then I'm going to write the cosine of x with the dx, which is going to help me with my use substitution. Now what I'm going to do is do a use substitution where this part is my du. So if cosine of x dx is du, that would mean my u should be sine of x. So if I want to do a u substitution, I'll be able to substitute cosine x dx with du. Sine squared will become u squared, and then I just have to figure out how I'm going to substitute cosine squared in terms of u. Well, this is where the trig identity comes in handy. So I know that sine squared plus cosine squared equals 1. So what that means is that cosine squared is equal to 1 minus sine squared of x. So I can rewrite cosine squared as 1 minus sine squared, and because u is going to be equal to sine, this will eventually just be 1 minus u squared. Okay, so I save one of my cosines for the dx. I rewrite cosine squared using the trig identity, and I leave my sine squared of x. Now I'm going to do the u substitution. I'm going to let u be sine, and then du is cosine of x dx. So this becomes du, this becomes u squared, and this part becomes 1 minus u squared. Now this is a simple integral to evaluate. I can distribute my u squared. So this integral will be the integral of u squared minus u to the 4th du, and then u squared goes to u cubed over 3. And then I have minus u to the 5th over 5 plus c. And then don't forget our u substitution, u equals sine of x. So in the end, I'll get sine cubed of x over 3 minus sine to the 5th over 5 plus c. So nothing new here. We simply did a u substitution, and then right here we used a trig identity. This will work for any powers of sine and cosine if we have one of the powers is odd. So in fact, we have some general guidelines. If we have an integral involving powers of sine and cosine, and one power is odd, we can do a u substitution just like I did in the last example. In the last example, we let u be sine. That's because cosine was the one with the odd power. So if it happened to be that sine was odd, we would save one of the sine functions for our du, and we would let u be cosine. Okay, so in some cases you let u be sine, and in other cases you let u be cosine. But one of those u substitutions will work when you use it with the trig identity. The only other thing that can happen when we're looking at powers of sine and cosine is maybe both of the powers are even. In this case, we can't do a u substitution, but there is another method that we can do. We can apply those half-angle identities that I discussed on the first slide. We'll show an example of this in the next video.